All right, everyone, thanks for watching and welcome to our lesson on the real number system. We're going to start out first by just talking a little bit about our calculator so that we can become familiar with it. You are going to need to be using your calculator a little bit as you go through this unit. At least it'll just kind of make some of the conversions go a little bit faster. So let's talk about some of the buttons that you kind of need to know. So first of all, let's start out with our computational buttons here. Now those are your normal, you have normal buttons that you would use to divide, to multiply, to subtract, to add. This button down here where it says enter is actually your equal button. Okay, so and then of course you have your numerical keys, which are there in white right here. And then you have like your decimal point. One thing that sometimes people get confused is the difference between the minus sign and the negative button. So this button here is to subtract. Right, subtract instead. This button here means negative. So just know that there's a difference between the button on the gray button over here that has a subtraction sign. That's the actual subtract button. But the button down at the bottom in white is to make a number negative. And you cannot use them in the same capacity. They have to stay separated. Okay, so let me just kind of zoom out a little bit. The other button that I really wanted to make sure you are aware of is the second key. The second key is kind of like a shift. It's right there. So if you notice above all of the buttons, there's a bunch of information that's written in blue. See, there's all of these blue words that are written. There's a quit right there. There's letters, all kinds of things that are written above the buttons, but notice that they're in blue. What this means is that you have to click the blue button in order to get to them. One of the numbers that we're going to be using pretty often this school year is the pi button. Now, pi is right above this caret button, but it's written in blue. That means that in order to get to pi, or in order to have it show up on your calculator, you first have to click the second key, and then after you click that, then you click the pi button, and that will have pi show up on your calculator. Okay, so let's start out by talking and giving examples of the numbers that are in our natural number group. These are numbers like 1, 2, 3. I could keep going all the way up to 42. 4-digit numbers like 5,000. So pretty much just your normal counting number starting from 1. Remember that these numbers, even though they're whole numbers, they can be written as fractions. So something like 3 is also the same as 3 over 1. Technically, because 3 over 1 simplifies to 3, it's still in that natural number group. Okay, so let's move on to our set of whole numbers. The set of whole numbers, if you look at the box that we have here, notice how it's bigger than the natural number box. Well, that's because it has a little bit more in it. It still has all of these natural numbers are inside of the whole number group, but it does have this extra component because it's a little bit bigger because it has an extra number, which is the number 0. So it still has all these natural numbers like 1, 2, 3, 42, 5,000, and they can still be written as fractions like we saw here, but it does have that extra 0. So then we take all of our natural numbers, we take this extra 0, and we build a bigger box which is our group of integers, and we do that by adding in all of our negative numbers. So we have these extra numbers like -1 or -5, which can also be written as a fraction, -5/1, same thing. You have numbers like -1,000, maybe -72, -40. So all of those negative numbers combined with 0, combined with the natural numbers, make this giant box of integers. All right, so now we're going to grow our boxes. We're going to grow our number set. And, we have not talked about, we've talked about fractions, but all of the fractions we've talked about can actually be simplified to whole numbers. So let's talk about the fractions that can't be made into whole numbers. For example, 3½ which is the same as 7/2, or -12/5, also a fraction. Maybe you have 60%, and if you remember working with percent, that's the same as 0.6. It's a decimal. It's a piece of a number. It's not a whole number in itself. So our set of rational numbers you see how this box is really big on the outside. Well, that's because it has all the natural numbers. It has the 0 for the whole number group. It has all of the negative numbers as well. And this box is so big because not only does it have all of those 3 pieces, it also has all of your fractions and decimals that are all of your fractions that are in between. Notice I kind of corrected myself. I didn't say fractions and decimals because yes, there are some decimals, but all of the decimals that are in this rational number group can also be written as fractions, which brings us to the new group that we are studying in 8th grade, which is our irrational group. Now, these numbers are numbers that cannot be written as fractions. So some of the numbers that you might see here are numbers like pi, for example, maybe 2 times pi, maybe the square root of 7, and we'll talk about square roots a little bit later on, but I want you to know that a lot of the square roots do come out to be irrational, maybe even 1/pi. Looks like it's a fraction, but when you type it in, what you end up getting is this really long decimal with no pattern, no repetition in it, and it turns out to be an irrational number. So rational numbers, I guess you could think about it, are your like nice, really clean decimals that come to a stop or repeat, and irrational numbers are those numbers that are really long and kind of crazy. Now, you do have to be careful with numbers like pi in your calculator because you can see I typed in pi, I hit that blue button that we talked about and the caret key, and I pressed enter, and if you look at the number that it gives you, it looks like the number comes to a stop, but it actually doesn't. If you look at the way the decimals are written, you'll see that there kind of is there's no order, there's no pattern. So for the purpose of this school year, if you end up seeing a decimal like that, chances are the calculator is cutting it off and rounding it for you, and it's not showing you all of the rest of the decimal places. So even though your calculator makes the decimal come to a stop, pi is actually an irrational number. Alrighty, so now let's look at some of the big characteristics of rational and irrational numbers. So let's start first. A rational number is all of the positive numbers, negative numbers, and 0 that can be written as fractions. And remember that it's really important that the denominator is not 0 in these examples. So when we were looking at our notes, some examples that we gave is something like -5 that can be written as a fraction of -5 over 1. We gave examples like 6.67, which can be written as 67 hundredths. So any number that can be written as a fraction makes it rational. And then another thing that's really important is that rational numbers have this subset of integers, whole numbers, and natural numbers. So remember, all of those groups are kind of underneath inside of the rational number group, So what does that look like? So that's why we had that Venn diagram. Here are our rational numbers. Inside you have the integers, inside you have the whole numbers, and inside of that you have your natural numbers. So all of those subsets are inside of the rational number group. So now let's go over to the irrational numbers. Now irrational numbers are a little bit different. They're the exact opposite. They cannot be written as fractions. So that part of it is just really important. We talked about some numbers like pi, like the square root of 19. When we put those in, whether we put them into the calculator, remember the calculator can be a little deceiving, but you'll see these long, outrageous decimals. And what's important about those decimals is that the decimals are non-terminating, which means they don't stop, and they're non-repeating. Okay, so now let's look at the bottom of this worksheet. And in order to kind of answer this, we're gonna need to have our Venn diagram readily available. So here's what we are going to be asking for this set of questions. If a number is an integer, it is also so we're going to look at this box of integer group, and what we're going to do is, since they want us to focus on the set of integers, then that's really all I'm going to focus on is this set right here. And I want to know what is the set of integers inside. What other groups is it a subset of? Now, this can be kind of confusing because a lot of people want to say whole and natural. But that's not true, because the whole and natural are inside of the integer group, and they're smaller than the integer group. For it to be a subset of something, then the other sets need to be larger. So it is also a rational number and a real number. So again, if a number is an integer, it's also rational and real. What about so let's kind of back up. What if the number is a whole number? So now instead of looking at the integer group, now we're looking here at the whole number group. So we have that box, and what the question is asking is, what other boxes is this inside? It is also a integer. It is also rational, and it is real. So let's look at a little bit, kind of erase that, and now let's look at the next number group that it's asking for, which is the natural group. That teeny tiny box. I know it's the smallest box, but it actually is in all of the other categories. So my natural numbers are also whole numbers. They are integers. They are rational. And they are real numbers. So finally, it brings us to the last set that it's asking for, which is the irrational group. Now check this out. The irrational group is way over here by itself. And notice how it doesn't touch any of the other groups. So, except for the real number group. So if it's irrational, the only other thing it can be is real. It's also a real number. So let's just kind of repeat that one more time. Our set of natural numbers are the set of positive whole numbers, excluding 0. That means it doesn't include 0. We talked about how these are like our counting numbers, like 1, 2, 3, so on. We talked about some of those much larger numbers that are also in this group. Then we said that when we get into this whole number group, it's not just one thing, which is the positive whole numbers. It also has, not only does it have the positive whole numbers, but it also has the 0 included in it. Now, as we grow our boxes, as we grow our number sets, we go from, yes, we have positive whole numbers, which you'll see right here. Yes, you have 0, but you also have those negative whole numbers, like -1, -7, -9, and as far up as you can count. Then we talked about rational numbers. Rational numbers are any number that can be expressed as a fraction. So there's the official definition. Make sure you know it cannot have a denominator of 0, and that the decimals that we see will either terminate or repeat. Now what this means is, again, terminate means come to a stop, like 0.72, which is the same as 72 hundredths. So still a fraction. Or a repeating decimal, like 1/3, which is the same as 0.3333. Now, all of these make up our rational number group, which is this big box. Outside, over here off to the side, you can see it's totally separate. You have your irrational numbers, which are those numbers that cannot be expressed as a fraction. You are going to have some really crazy decimals there. The numbers do not terminate, they do not repeat. And we gave the example of numbers like pi or the square root of 17. Those types of numbers where you're going to see some pretty outrageous decimals. Now, when you put these two groups together, that's what makes our set of real numbers.